Hello everyone, we meet again for the last video of the Bivariate Statistics chapter, which is about prediction. To introduce this topic, I suggest you rediscover the general outline of the chapter, thanks to the very first slide that I displayed in the introduction and which explains the aims of the chapter. We're talking about a study that consists of two characters. That is to say, two questions were asked to each individual of the study, and that led to two answers, of course, so a pair of answers. I took the example of companies from which we took the expense in advertising, denoted X, and the revenue that followed the advertising, denoted Y. The expense revenue led to a series, a data series of values. So each individual, each company here can be considered as a pair XY and can be placed somewhere on the graph. For instance, this first point is one company that had an expense of approximately 3,000 euros in advertising and which revenue was approximately 94,000 euros. One other company had another point with another value of X and another value of Y, and so on. There are here 14 companies in our survey. This time, you can see that you obtain a whole data series, okay, a whole list of pairs XY. And you have to be able to see or not if there is a global trend. Does the point cloud has some shape? Okay, so you can see in my example an elongated shape in a certain direction into the plane with a certain slope from the horizontal. The first question of the chapter were or was, are X and Y related? That's named correlation. Okay, you're looking for some correlation between variables. You can see that here in the example, there is a correlation. It seems to be a good correlation between variables, even if from point to point, you can't say that Y is an increasing function of X. For a company whose value of X is bigger than another company, the value of Y is not always bigger. But generally, the global trend is an increasing value of Y with respect to X. The second question was about modeling the relationship. It consists in finding a curve or straight line that goes through the point cloud and tries to follow its main axis. It's named fitting or regression. So if you perform the right or a right regression among many possibilities, you will obtain maybe this kind of curve that shows you the average trend of the cloud, of course. And then we go to the last question, which is the purpose of today. It's prediction. Can we estimate new unknown values thanks to the known values? For example, if a company wishes to expend 12,000 euros, what is the revenue that it can predict? A first prediction would be what we call a point estimate. You just have to go to the curve, okay, and to use the point, the right point on the curve, to calculate the value of y, that is your expectation. So it's named point estimate, and that's what we're going to do for the beginning. Your methodology here is very simple. First, you have to know the expression of your curve or straight line. Then, you have to know at what location you want to establish your prediction. So this location was 12 for my example. So it's a given value of x or y that is given in the statement in the exercise. And then you have to use the expression in point 1 to calculate the other variable that will be your prediction. Let's take the exercise 19 as an example. This exercise contains 3 questions, taking back 3 different exercises. So, the exercise 10 in the first question was about the expense in advertising of a company through time. So, the first variable, x, was time, and the second one, the evolution of the expense. We found out that the regression straight line had an expression which is this one, y prime equals 7.0629x plus 37.42. So by the way, I have to put a prime on y, okay? It's not y, but y prime, because we don't have to make any confusion between y and y prime. Y is the ordinate of a point of a cloud, and y prime is an ordinate that we can calculate in a curve. Well, in exercise 19, question 1, we want to make a prediction for the year 2020 that's equivalent to a value of x that is 14. So why? Because in the exercise 10, we took the year 2007 as x equals 1, the year 2008 x equals 2, and so on. So x equals 14 for the year 2020, sorry. Third, we have to calculate y prime 0 for having your prediction. So here, it's just a simple calculation inside the expression, and the result will be this one. Let's take now the exercise 7 in the second question. This was our example of harvest with respect to the quantity of fertilizer. The quantity of fertilizer is the variable x, and the harvest, the variable y. And the expression of the straight line that have been used as a model here was this one. This time the question is, what is the quantity of fertilizer to be put if we want a harvest of 60 hundreds of kilograms per hectare? So our goal is to reach the value 60 for y, and the question is about x. A simple calculation with a first degree equation leads to a value of x that is 335.4 kilograms per hectare of fertilizer. Last example with the exercise 15. In this exercise, x was the speed of a vehicle and y was its consumption. This time, a linear model was irrelevant, and we achieved to find a quadratic model, so thanks to a second degree function. This was this expression. If you put x in kilometers per hour in this expression, you will be able to calculate the prediction of y consumption in liters per 100 kilometers. The question is, what is the expectation of the consumption if the speed is 100 kilometers per hour? You put that in the calculation and the result is 11.91 liters per 100 kilometers. Okay, so point estimate is very easy to do. But we won't stop here in the chapter. We have to go further. Let's take back my first graph. My first graph shown a point cloud, and this point cloud shown a regression line, which is here a curve. The question is, if you want to estimate unknown values, maybe the fact to mention only y prime 0 is not enough. Maybe we would have to take into account the shape of the cloud and more precisely the width of the cloud. Okay, it has a width around the curve. If you take it into account, maybe you will be able to make an estimation thanks to an interval with a lower bound and an upper bound. The first idea could be to, perhaps it would be a good idea to consider the points of the cloud most distant from the regression curve and take only them into account in order to mention an interval in the end above 12, of course, so at the right location in the graph, to make a prediction of y prime. So it wouldn't be a good idea since we don't master the confidence level of such an interval. We don't have a handle on the confidence level because we don't know if some red points or new red points that we can't see here would be outside this interval, okay? Outside the two brown lines. So it's not something that we can master. It's impossible. So let's forget about this idea and consider dotted lines here that just appeared in blue. In this model, we must consider that we have to take into account an average distance of the cloud points compared to the curve. And these dotted lines take into account the average distance, okay? The average variability of the points around the curve. So let's introduce this method. And let's finish here by putting in blue a first interval that we could mention. And the little problem is that this first interval wouldn't lead to a good confidence level in the end. So you could name a prediction thanks to this interval, but the chance that the right future value of y would be inside this interval are not very big. They are approximately 68%. Okay, it's just because we're taking into account an average distance around the curve. This 68% comes from the normal law, and we will see normal law next year. Okay, so I don't say much about that this time. So if we would be able to increase our confidence level, we would have to enlarge this interval, okay, to make its size increase. And of course, what appears here in red is a better confidence interval in terms of confidence level. Of course, the greater my interval is, okay, the bigger it is, and the more my confidence level will be big. Okay, the bigger the confidence level. So let's now explain exactly the method that we'll employ and the calculations and computations that will be necessary. The first point is that I have to take another graph, another point cloud. Our method only works with straight lines as regression lines. Okay, so it's not a big problem, since we saw earlier in the chapter that if we want a curve to model a point cloud, we have to make a variable change that leads to a linear regression. So at this point of the method, if you've got an expression of a straight line, you can make your prediction, and you will be able to translate it later into some curve. The second point is more restrictive. If we want our method is right and describe the reality as well as possible, we have to have a positive linear regression coefficient. That means a positive covariance and a positive slope for the line. Okay? In case of decreasing values of y, this method is wrong. That's all. So let's take our y prime 0 as a central value of a prediction, and let's take into account the average distance of the points around the line. So always, and again here, by the mean of two dotted lines. So in this model, we must consider that the more x and y increase, the greater the possible variability around the line. The dashed or dotted lines that appear represent the average thickness of the cloud, but they widen. It means that their distance increase with x, their distance around the line. Okay, so the more x and y are big, the more the possible variability will be big. Okay, so it's an assumption, but that corresponds to many concrete situations. So these dotted lines are obtained by calculating a relative and not an absolute standard deviation, which is that of a new variable z, defined as the ratio y divided by y prime, and which effectively introduces this notion of relativity. So let's take two examples in order to talk about this term relativity that leads to this amplification on the graph. If you consider the very first point of the cloud on the left, okay, maybe the ratio y divided by y prime would be 0.95. Okay, you can say that y, the ordinate of the red point, is a bit less than y prime, the ordinate on the line. So why not 0.95 in the end? It means that the height of the point is 95% the height of the line at this location. Okay, you've got a difference of 5% in height between the point and the line. If you go to the, I don't know, the third point of the graph, it's a little above the line. Maybe the ratio would be this time 1.1. If this ratio is 1.1, it means that the point is 10% above the line here. And the ratio z allows us to talk in percentages. And talking like that is talking about relative distances, okay? Distances in percentage. So this will be very important for us because it will allow us to make comparison between every point of the cloud, each other. So let's go further now. We must perform a second amplification in the end. As I told you earlier, to take the confidence level into account. The blue interval has not a so big confidence level, around 68%. With a second amplification, maybe 1.5 or 2 or 2.5, you will make your confidence level increase. So this second amplification, let's read what it is, has to be, this interval has to be amplified by a coefficient that we will name u, related to a given higher confidence level. And we're lucky because the normal law that is behind all of that allows us to know a value of u matching every possible confidence level. For instance, if you want 95% confidence in your prediction, you know that your coefficient must be equal to 1.96. Another used confidence level, 99%, okay, very commonly used, corresponds to a confidence coefficient u to 2.58, and so on. Okay, so that means that for a 95% confidence level, 1.9896 coefficient, you have to amplify by a factor of almost 2 the blue interval to create the red interval. Okay, let's say now what you had to be able to do in order to perform an exercise. Your methodology is this one, this time. The first point is to analyze the point cloud by the values of z. You have to be able to calculate all the values y prime coming from the point cloud. Then you calculate the values of your new variable, and finally to get its mean and standard deviation. In the second point, you have to calculate the point estimate, which will be the center of your future interval. Then you have to choose the right coefficient u to imply the right interval. And then the interval and its calculation will be given by a formula. The exercise 20 goes back to the statement of exercise 9. It may be a mistake, and I think it's exercise 10. Well, whatever, we've got the time series of the expense of a company in advertising through time. So the first variable is time, and the second one is the expense. Here is what you have to get into your calculators. The two first lists come from the statement of the exercise, the data series. So X for the years and Y for the expense that are given. In list 3, you must be able to ask your calculator to calculate the whole set of Y prime values. Y prime are all the values that can be calculated on the line. And if you have to consider the expression of the line, ax plus b. So in list 3, at this location, you have to ask a formula that is a times list 1 plus b. Okay, ax plus b, with the coefficients a and b of your exercise. Then the results will be these. In list 4, you have to calculate the ratios y divided by y prime that are corresponding to a formula in your calculator that is list 2 divided by list 3. The results turn around 1. Some are a little less than 1 and some a little more than 1. Okay, it's the translation of the fact that the points of the cloud turn around the line. That's all. So the first point is 92% in 8 compared to the line. The second point is 16% more than the line in terms of the value of y, of course, and so on. You have to, for finishing the first point of the methodology, you have to be able to get the average value and the standard deviation of this variable. For the first time, and the only time in this chapter, you have to ask your calculator to perform one variable statistics, because you're just interested in the result of list 4. So you just have to ask it to a calculator, and then the results will be a mean of that is very, very close to 1. The values of the turnaround run and its average value is always very close to 1. If not, it means that you made a mistake somewhere. The standard deviation is the most important information for us, and here it's 0.125 and so on. By the way, that means that the average distance between the dotted lines and the straight line is a difference in height of 12.5%. Second point, which is completely independent of the first, we are beginning to perform our estimation. Okay, the first point is no estimation. The first point is an analysis of the point cloud. In the second point, you want to make a prediction for the year 2020. And we already done it, okay, at the beginning of this video. So I'm just pulling back the result, 136.3 kilo euros. Sorry. The third point, confidence level leads to a coefficient U. We want a 95% confidence level, so we have to use a coefficient U that is 1.96. So you can't calculate it, okay? It's just given. Then you've got the whole set of necessary information in order to put all that in the formula of the interval. By placing it, you will have to calculate two bounds, the lower bound and the upper bound of the interval, and the results are like that. 103 on one side and 170 on the other side. You can round the result, okay? It's not very important because you made a prediction using tools that represent correctly the reality, but not exactly the reality, okay? So 103, 170. You can notice that this prediction is not accurate. And it's a fact that a confidence interval is not meant to be accurate. A confidence interval is important for its outside. Let's talk about that. If you have 95% chance that the new next value will be inside this interval, it means that there are only 2.5% chance that it would be under 103 and 2.5% chance it would be over 170. So if someone asks you to perform a study and to make a prediction for a budget, for instance, you can tell this person that it has to forecast at least 103 kilo euros. And you can tell this person that the expense won't exceed 170, okay? Because there are very few chances that we would expect 170. So let's see it quickly on the second example with the case of fertilizer and harvest. This time our two first lists are these ones coming from the exercise. The expression of the line has been obtained earlier, and thanks to it you can put a formula in list 3, taking A list 1 plus B. Then in list 4 you can calculate list 2 divided by list 3, and here are the results. Again, some values turning around 1. The average value of z is very close to 1, and the standard deviation is this value that will be used in the formula. The second point makes us begin the prediction. The purpose here was to make a prediction of the harvest if we consider 300 kilograms of fertilizer. So you just have to put 300 instead of x in the expression and finish the calculation. The mean expected harvest is 57,000, no, not thousands, hundreds of kilograms, sorry. Third point, the confidence level is asked by the exercise at 99%. So you have to use coefficient U equal 2.58. The result will be this. And you can say, and you will be able to say to the farmer, for instance, that his harvest will be at least 50 hundreds of kilograms. Now, let's finish by an exercise which is a bit more complicated. It's more complicated because in the exercise 22, you've got a crossed table. So you've got values of x in columns and values of y in rows. And at each crossing of one x and one y, you've got several individuals, not just one. So you've got 3 different information in this table. Plus, your calculator doesn't understand cross tables. You just have to put the same data series, but in lists. You will have to use one list for x, one list for y, and one list for the frequencies, that are the numbers of individuals of each crossing. You have to mention each or every possible crossing of x and y. Since you've got 4 different values of x and 3 different values of y, you've got 12 possible crossings. And matching the 12, you've got the number of individuals. For your calculators, it's named frequencies, so frec in the calculators. In the whole exercise, you have, in every question, you have to tell your calculator that you've got 3 lists. And the most important, that you've got frequencies in list 3. If not, your results will be wrong. Anytime, any results, and so on. Okay, so don't forget that. The expression of the straight line here is this one, obtained by asking your calculator a linear regression. This expression helps you to calculate in list 4 the values y prime, which are negative 0.008430 times list 1 plus 1.0424. The results are these ones. And in list 5, y divided by y prime, that is at the formula, list 2 divided by list 4. In order to obtain the result of average value and standard deviation of this new variable, don't forget to tell your calculator that there are frequencies in list 3. The results will be this one for the mean and this one for the standard deviation. Now, let's perform the prediction. We want a prediction of the visual acuity of people that are 80 years old. So, by the way, the values of x at the very beginning were age of interviewed people, and the values of y were their average visual acuity. So there is a global trend, okay? The visual acuity tends to decrease as the age increases. And the aim of this exercise is to make a prediction for 80-year-old people. So if x equals 80, and thanks to the expression of the straight line, your average prediction will be a visual acuity of 0.368. Now, the confidence level of the interval is at a 95% level. So u equals 2.58. You just put your information into the formula and reach this result. We could round it at 0.1 or 0.09, okay, for the lower bound, and 0.65 for the upper bound. It means that 99% of the 80-year-old people have a visual acuity between 0.9 tenth and 6.5 tenth. Okay, because in terms of visual acuity, we are talking in tenths. Okay, it means that 0.5% of the population has a visual acuity below the lower bound, and 0.5% of the population is above 6.5 tenths. Okay, that's what it means here. Okay, thanks all, and I'm waiting for your comments that I will answer, and I hope there will be a lot of comments. Thank you all, and I see you in the next video. Bye.